There are actually two ways to create pollers or custom pollers. The first way is the Device Studio that you can find right within the web console. Device Studio was the second of two poller tools released and fills some specific functionality gaps in the original tool. Most notably, the ability to modify existing resources such as node details. And previously, customers had to use the original UNDP tool to build individual resources for each line in node details that the default poller was missing. And this led to several resources and a lot of scrolling. So the Device Studio can poll for multiple OIDs for a technology. It can poll single CPU and RAM and poll for multiple CPUs and RAM. It can also poll for additional node details and perform logical operations for custom polling. With Device Studio, you can display custom polled values in existing resources such as vital stats or node details. This is the ability added to this feature that allows for inserting data into the node details resource, something that was a popular request. Because the tool was designed this way, you can only build pollers for CPU, memory, and node details with this tool. The technology is very specific, and for anything outside CPU, memory, and node details, you would use our other tool. However, for those technologies, this tool is very effective and the preferred method for polling that data. So the other tool, or the original tool, is called Universal Device Pollers, or UNDP. That's the second method. And you can find this in the SolarWinds program files folder and is independent of the web console. You must RDP to the application server to use this tool. UNDP can poll only one OID. Polled values are displayed in dedicated resources in the web console. They cannot be placed in existing ones. And it can also perform logical operations. Now let me demonstrate how to create custom pollers for a device. We will use the AdTran1335 to build a poller for CPU and memory utilization using Device Studio. First, I'll switch to our device's node details page and look at vital stats, which can be found right here in the sub view pane. Apparently, this view does not show a resource for CPU and memory used. So we'll use this as our example to demonstrate building custom pollers using Device Studio. I'll go back to Node Details page. Remember that you need to obtain the OID or OIDs for a metric that you want to poll. This has to be done before you build a poller. Since I already researched for the OID, I can use the MIB browser to search and ensure that the OIDs I will use are already in the MIB database. So let me put the OID and click search. Okay, so our search worked, so we're good to go. Now, if I expand the tree based on our OID, we should be able to find the metrics we're supposed to create. Starting with CPU load, let's see this, and this is what we're looking for, so I can take note of the specific OID and use it later for building our poller. We are also looking for memory used, and it looks like that there is no specific OID for that stat, but we can calculate using the memory heap size, the same as total memory, and total heap free for free memory. We will obtain the total memory use by subtracting the total heap free from the total heap size. So I have already taken note of the OIDs we need. So let's go to the next step. So I'll go to settings, all settings, and click on manage pollers. The Manage Polars page displays polars that come out of the box. And this is named as SolarWinds Native Polar and SolarWinds. It should also display custom polars if you have created one. On this page, you can also turn the polar on or off. You can assign it to a device and even edit existing ones. You can also directly import polars shared in the Thwack community if it matches your device. But in this demo, we're going to click on Create New Polar for our CPU and memory utilization. So now you will be presented a quick guide on how to create polars. It's going to give you a few tips when building one. So let's go ahead and click on Get Started. First step is to define the general parameters. This is where you can specify what type of data or technology you want to pull. Remember that Device Studio only supports the following technology: single CPU and memory, multi-CPU and memory, and no details. I will select single CPU and memory for our polar, then specify a meaningful name for your polar. Let's name that as SolarWinds or SW-Polar1, and then select a test node. This is only the node to test the polar against. It does not assign the polar to that node. So we'll select our device, Adtran1335, and click Submit. You may also put tags, which is optional. You can put description and author for efficient searching. But for this exercise, I'm gonna leave it blank and hit on next. The next step is to specify the data source. So we have the total memory, free memory, and CPU load. Let's start with the CPU load and click on Define Data Source. So we'll do that for each of the OIDs that we have searched in the MIB browser. So starting off with CPU load, remember I have taken note of the OID we've searched a while ago. Click Search. So there you go, we have one result. If you select that, this will display the information about that specific OID. As you can see, the description says average CPU utilization over the last second, its OID, from what MIB, the type, and so on and so forth. If you scroll down a little bit, there is an option that says manually define object identifier. Note that you may not have updated the database for some reason. That means OID is not in our database. So you may use this option to define the OIDs manually. But I recommend using it on a short-term basis if you have to see the data now and cannot wait for 2 to 4 weeks for a MIB database update. Once you have the update, you will want to switch your polar over to the OID and away from the static value for a couple of reasons. First, this feature does not add the information to the MIB database. The platform or the network health and performance monitoring is designed to function around the MIB database when it comes to SNMP. Full functionality of the product is not guaranteed for anything outside the MIB database. So let me select the OID again and hit Submit. Now we're looking at the current result and it says 8%. Now if you feel that the value is reasonable, you can go ahead and click on yes, the data source is reasonable, and that value will be displayed in this column. Now let's do that again on free memory. So we'll just repeat the steps. I'm going to paste the OID here, search, select, there's the description, scroll down a little bit and hit submit. And if the result is reasonable, then go ahead and click yes, the data source is reasonable. Then for used memory, this is quite a different process since it involves calculation of subtracting free memory from total memory to arrive at a value for used memory. So let's do that. First, let's search for the OID of the total memory size. Select and submit. Before we go ahead and click on yes, the data source is reasonable, we must add an additional OID so that we can go ahead and create a calculation based on the OIDs we've searched. So I'm going to select an additional OID and search for the heap free. Select and submit. So we have heap free and heap size. Now we can go ahead and add a calculated value. Let's select the input. First is the total size minus heap free. You can go ahead and click on test and you have your value for used memory. Let's click on submit and you have that third value for your used memory. So since this looks good, we can go ahead and click yes, the data source is reasonable. And we all have the value for all OIDs we have selected. Let's now hit on next. Now in the discovery settings, you have this option automatically poll nodes during network discovery, add node, and least resources to determine if this poller is a match. Checking this box automatically polls all nodes monitored that support these OIDs. In the future, any nodes added that support the OIDs will also automatically be pulled and show in list resources. Right now, we will uncheck that box so that we can assign the poller later. Hit next, review, and then submit. This brings us back to the manage pollers page. Now let's find the poller we created. If we look at the group by author, there is one unknown here. Let's click that. This is what we created a while ago. Remember, we did not specify the author name. That's why it's unknown. The SW-poller1 is currently turned off. You can turn on using this button. So let's do that. This is now turned on, but not assigned to any node. Click the unassigned button so we can assign it. Okay, now let's find the AdTran device by changing group by to vendor. So it's easier to find that way. So here's our AdTran 1335. Let's click Scan Now to pull the device immediately. This will also automatically turn the poller on. In this environment, it shouldn't take a little bit of time. The scan result shows an exact match, so we're good to go. Now let's return to the node details page to see the desired result by clicking on this node. This could take a few minutes to show up for this device as the polling has to be complete. There aren't too many nodes in this environment, but poll now puts the polling to the top of the current polling queue, which could take a minute anyway. So just continue refreshing until the data shows. So let me switch back to vital stats and see if we have the desired result. Now we're seeing the data from our custom poller. So it's a success. From this point forward, this data will be pulled on the same interval as any other statistic on the node. You can click edit here to change the gauges, but right now we have the data already. Couple of things to note. This resource for the CPU in memory is hidden in this view if not used. So it automatically became visible with our custom poller. Important to note, as if you ever want to stop getting data for whatever reason, or if this custom poller is deleted, this resource will still show, but will just continue to show the last poll data, meaning it's stale data, which won't be accurate. You can get around this by deleting and re-adding the node, which will reset the resources. If you're not comfortable with doing that, you can just delete the resource. Show the data will still be in the database, but you won't see it. Resources can be added back later. Now I'm going to demonstrate creating custom poller using an older tool called the Universal Device Poller, or UNDP. We will use another device, and right now I am in the node details page of our Foundry 624 device. Remember that when creating custom poller, you must obtain the OID for the metric already. So I have that, and we'll use that in this demo. There really isn't any hardware monitoring here, so we're going to add some. First, a poller for temperature. Next, a poller for power supply and fan status. We'll have a resource for these pollers with gauges and everything we have with out-of-the-box poller. Now let me switch to the UNDP application. Okay, you can launch the UNDP application from Program Files and then SolarWinds. You can click that right here and find the UNDP application, which is right here with a leaf icon. Okay, so UNDP is a backend application and not web-based application. Some basic calculations are possible with transform result here, and we'll look at that. We'll start with a poller for temperature on this device. So let me click New Universal Device Poller. Okay, so right away we need the OID. Good thing I looked it up, so I'm going to paste that. But you can also browse the MIB tree if you choose. Now the manufacturer measures temperature in Celsius and 1/2 degree, so we'll fix that later in this exercise. So I have supplied the OID. Since this is in the SolarWinds MIB database, I can see the name and then the description supplied already. So that means this is the OID I want. Let me click on the advanced option. This lets you configure SNMP, polling, intervals, and other values. In this example, we'll just keep the default, so I'm going to minimize that. Keep historical data, yes or no. The data will automatically show in the web console. This option here is for storing in the database. And here are a couple of questions to ask yourself before choosing between these options. First question is, do you want charts, graphs, and reporting on historical data? Do you want to alert on this poller, or will you be using this poller in any perf stack troubleshooting view? Is this poll data what you will be interacting with, or are you going to transform this into a more usable format? In other words, is this just raw data you'll never interact with? Because you can choose to save historical data in the transform tool. So if checked, the data will take space in the database. Always consider that with this option. No option will allow me to see current data in the web console, but nothing historical will be stored or an option to display. For this one, since I'm going to transform this data into a more consumable format, I'm not going to keep this raw data as I'll never interact with it. So there's no point in it taking space in my database. Status is enabled. That's fine. And underneath you have the status. Let's keep it enabled. And group. This is a way to organize pollers in UNDP. Default is fine, so I'll hit next. Next is to assign nodes and test. With UNDP, you assign nodes and test at the same time. Be very careful with this window. If you select numerous nodes and click test, it will test against every single node. This can cause significant performance issues on your platform server and has happened many times to customers over the years. So test your poller against a small sample or handful of nodes, then go back and assign to other nodes. So I'll find my node and test. Here we go. Test. All right, so we have the value there. Let's try to select another node here and do a test, this time for another device. The reason I did that is to show you the errors. On Adtran node, the OID is not supported. When the OID is not supported, UNDP will let you know. So I will deselect that and hit next. And remember, this temperature right here is temperature value 1/2 degree intervals. So this is essentially double the actual temperature. And considering this is Celsius, we can go ahead and transform that to Fahrenheit. So let's hit next. So here you choose the view. The available boxes are active and grayed out for the unavailable boxes. We have to make additional calculations on your temperature. So for now, we'll say no for it appearing in the web console. And we can change that later. Let's hit finish. Now the poller is created and it can be modified. Right now, let's hit transform result. This will let me change my temperature to full degrees and even from Celsius to Fahrenheit if I choose. So let me hit next and let's define the transform. I'll just name this SolarWinds Polar Transform. You can put description if you choose. Keep historical data. Now I will keep the data as this is the final format and what I will be interacting with. Status is enabled. Let's leave the default group. And for the polling interval, I'm going to leave that blank to use the network health and performance default polling interval. Hit next. Now here's where you define the formula. So first, let's choose a polar. And what we're looking for is actual temperature. So what we're going to do is divide the results by 2 to get an accurate reading. Since this is 0.5 value temperature. And then let's select the Foundry device and test. Okay, so I think this result look correct for Celsius. I'm going to convert to Fahrenheit so it's easier for us. So let's add a function and look for temperature and choose Celsius to Fahrenheit. Now I can copy or cut the formula and paste it inside the parentheses to complete this transformation and test. Now the value in Fahrenheit looks right. So let's hit next. And we will now assign this to the correct device and test. Looks great. Hit next. Okay, so for the view, I want gauges and I want it in vital stat. So I'll select those. I also don't want this in devices where it's not pulled. So I'll check that box and hit finish. Last step is to assign both the temperature and the transform polars to the right node, which I'll do now. So just collapse all polars and we put our polars in default group. Let's select both, hit next, choose the node, choose the node. Here's our Foundry 624 device and hit finish. Now we can return to the web console, refresh and pull until the data is shown. So let me do that. Okay, I'm back to the vital stats. Let me switch to summary so that I can click on poll now. Click poll now. Then let's switch back to vital stats. Let's scroll down a little bit and we have the temperature. Next, we'll add the fan status and power supply status polars on this same device. I have the OIDs already. So this exercise will use multiple OIDs, one for fan and one for power supply status, along with putting that data in a table. So it's a bit more challenging. So just for a review, we'll double check the MIB database and make sure the OIDs are there. So let me switch back to summary. Click the MIB browser. I'll check the fan status first. So we have 3 values here. Now let's try the fan status. Search. Select. And we also have 3 values on a table. So we'll talk about those as we build the polar and how to use them. So let me switch back to UNDP. Click New UNDP or Universal Device Polar. Paste the OID. In this one, we'll use the advanced options because we have to format this data. So let's find the format drop-down and see the options. Okay, operational status seems to be the right one, but when we tested that, it only gave an up or down status. So not quite. We'll use enumerate instead. Now I'll map those values to what I want to see by clicking Map Values button. Here I can assign statuses to these values we saw in the OID table where we had 2 as the values. So 1 is other, and I don't need that, so we'll leave it. 2 is normal. I'm going to make it a OK. And 3 is failure, which in our world is a red alert. Let's hit OK and minimize advanced option. This time, considering I'm using a table, I'm going to say no to keep historical data. That takes too much space for my comfort. Now let's hit next and let's choose the same node for testing to make sure all is good. Let's hit next. Now I'm choosing table and I can name my columns. The easiest way to do this is to find your node and click on test. So let's do that. Hit test. Okay, so this will show the actual table on your node, so you can map it correctly. I'm working with the fan, so I'll map my values to fan index and hit next. Now I want to put this in vital stats again, but this time as a table. And let's hit finish. Let's confirm is the polar is assigned. Looks good. Now confirm the polar is assigned. Fan status. Hit next. All right, so we're doing it again. Hit finish. Okay. All right, and now we can return to the web console and refresh for the data. And we should see that all three fans are all A-OK. But let's do that later on. First, let's add the polar for power supply. So we will just repeat the process with the power supply OID and add it to the same table.
To access the rest of this training series, log into your Customer Portal account at customerportal.solarwinds.com.